Hello viewers, welcome back to another section of my tutorials, and still on Applied Electricity tutorials. We have this circuit here, and it says we should calculate the value of this resistance R, which is unknown in the figure, so that the total current in the circuit is going to be 0.2 amperes. And it says what will be the potential difference between A and B, these 2 points. So let's see how we're going to solve this. Kindly watch this video to the end and don't forget to subscribe and like. So write my solution here. Because of redrawing, let me divide my sheets. So whenever you are being given a circuit which is electrical network, make sure you reduce the necessary resistance connection. So the question is asking us to find this R, provided the total current is 0.2 amperes. Meaning, to get this total current, we need the total R and we also need the total voltage. So let's see how to get a total R. So in finding the total resistance, we can see that our 5 ohm and this 5 ohm are in series. So we add that part. So we are going to reduce this electrical network to a simple one. Then we are going to apply our Ohm's law. So 5 and 5 are in series, that's going to give us 10. So if I'm to redraw, I'm going to get that part. Don't forget to be redrawing in applied electricity because it's a necessary tip so that you get most questions correct. Because if you don't draw, you end up making some mistake which you wouldn't identify. So I'm going to get my single here, that's the 10 ohm because I've joined the 5 and 5. I'll have my 30 ohm in the middle like this, and I'll have my 15 ohm nicely. So I'm having my total current here, which is 0.2. Here is still R. Then you have my 10 ohm here. Then I forgot, here is my 2 volts. Here is 2 volts. So at this point, I'm going to have my 6 volts here. So still reducing, I'm going to have this 30 and this 10 being in parallel because I can go through them without passing through any other circuit elements. So that is going to give me 30 times 10 over 40, and that is going to be what? 300 out of 40, and that would give me 7.5 ohm. 7.5 ohm. So at this point, still redrawing, I'm going to get my simple circuit to be like this and also like this, where this be 7.5 ohm and here is 15 ohm. I have my 6 volts, my 10 ohm, my 2 volts, as well as my R, my total current 0.2 amperes. So at this point I can clearly see that this and this are also in parallel, and the parallel combination is going to give me 15 multiplying 7.5, then all over 15 plus 7.5, and that is going to give me 5. So getting 5 there, my circuit still come back to this. So my R, then finally I'm getting 5 ohms here, my R, my 6 volts, my 2 volts, my 10 ohms, then my total 0.2 amperes. So at this point, as we have reduced this circuit, we can clearly show how to get R. So our final total resistance becomes 10 ohm plus 5 ohm plus R, that is RT. Now, since R is unknown, you will leave this as an expression as 15 ohm plus R, like this. They are all in series. Now let's see the total voltage VT. Now if I take the total voltage moving here in this loop, I'm going to get 6 minus 2 volts, and that will give me 4 volts. So I can see that my 4 volts, which is the total voltage, over my total resistance should give my total current, which is equal to 0.2 amperes. So this is going to be 4 over 15 plus R to be equal to 0.2. Now what I'll do is I'll exchange, and 4 over 0.2 will be equal to 15 plus R. If you have 4 over 0.2, the answer is going to be 4 over 0.2. The answer is going to be 20, sorry. So we're going to have 20 to be equal to 15 plus R. So our R is simply 5 ohms. Once you've got the value for R to be 5 ohms, the second part of the question is saying you find the potential difference between the points A and B here, and that is between this point and this point. But before we can do that, we have to combine this circuit to this level. So in our redrawing part, we arrived at this circuit, and which is a combine to this point A and B. So we have to find the total potential difference between this part, and the potential difference PD is simply equal to I times R, where I is the current through that branch, and the current through that branch here is 0.2 amperes. So 0.2 amperes times R, and our R is 5, and this is going to give us 1 volt. But let's see, in the question here was A and here is B, so we can easily see that this current is moving this way and another current is moving this way, but you can see that the stronger part or the effective part of the circuit is this part, the 6 volts, which is coming down in this direction. So it's moving against the points given A and B, so it's going to be negative. So potential difference will be negative 1 volt. Thank you. Kindly subscribe and don't forget to like.